Eddie, what did you have for lunch today?
I had some spring rolls from the leftovers from Saturday still that I'm still
Saturday.
going through.
Oh my gosh, I'm still thinking about some of those spring rolls.
The tofu was really good.
Yeah.
It was
Gio, how
pretty
about
good,
you? Gio, what did you have for lunch?
I tried making a fancy salad, but I just ended up throwing some mix and like dressing, and I just called it a day.
Yeah. Okay. Lucas, what'd you have for lunch?
Oh, I had Crossroads.
Oh, okay. I like that
The
place.
saddest answer yet.
I like that place. I love a buffet.
Oh yeah.
Hasn't it like gotten worse though? Like
Oh,
I
it
feel like that's what
has.
I've heard is that it's gotten a lot worse.
they finally let us do salads today, so it's okay.
Oh.
That's the saddest thing I've ever heard. We finally
JD?
got to eat vegetables.
JD, what did you have?
I haven't eaten yet, so
Oh
I'll
my
eat after the
God.
meeting.
There's some lentil soup in the cabinet.
Classic
And
Lena.
Pari,
Thanks,
Pari,
Lena.
what'd you have, Pari?
Yeah,
What'd you have for lunch?
I made a salad bowl, but it was a lot more potatoes than salad.
Oh, speaking my language.
I had leftover Chinese food.
Mm.
Cool. That my kids will have all rejected, so it's now all me. Okay, so I'm going to share my screen. Thank you all so much for coming. This is one of my favorite topics to talk about. I teach a class at Holy Names University where I teach first year teachers on how to teach and pedagogy and how to create an inclusive and welcoming classroom. And we talk about a range of topics, but this is one of my very first lectures that I do for my first year teachers. And I thought I would share it with all of you because I just think it's so important for all of us to know how our brains work. And so let me just share can you see my screen here? Yeah, okay, cool. So just to give you a little background, I don't know if I've told all of you what I do in my other life is I'm a school psychologist. I work in schools and I support mental health and special education. So the students I primarily work with are students who are struggling in some way, whether it's behavioral, emotional, academic. Those are the kids I tend to spend the most time with, and I do assessments. I counsel their teachers and I counsel their parents, and then we all sit down as a team and we talk about how do we make this child's school experience as positive as possible. So here at the Coder School, as you all know, I don't know how to code, I don't know how to program, but I do know how to teach and work with lots of different kinds of learners and kids. So that is the one value add I can add to your experience here. And I want you to tell me anytime if you ever have any student that you're struggling with or any student that you're observing, you know, is having trouble retaining information or focusing or paying attention, to please let us know so that we can help you strategize. We don't want your sessions to feel challenging or to feel taxing to you in any way. We want to try to pave that road and, you know, kind of be like helicopter parents, but for you, and when it comes to supporting your students. So I'm going to start by just giving you a quick rundown of what we're going to cover today. I'm going to start by talking about how babies' brains develop, how your brains develop when you were tiny babies, because I just think it's really fun to just imagine yourself in the context of, you know, being new to this world, and also kind of putting yourself in the position of how your students all grew up and developed too. So we'll talk about how all of your 5 senses developed and how language developed. We'll talk about then how to develop a healthier brain and some strategies and tips that that's the latest in the brain research right now. And the last 2 topics I really want to, that I find the most practical, is how to build executive functioning skills. Some of you might even find that you might find some of these strategies helpful for yourself. Because you may already know this, but the human brain, your brain is not fully developed until the age of 28. Now, as of about 10 years ago, that age was 25. But the latest in brain research is telling us now the human brain is not fully actualized, fully developed until the age of 28. So there are still structures building, growing in your brain if you're not yet 28. So we'll talk about building executive functioning skills and then how to support neuroatypical learners. So that's kind of the lay of the land. This is a very famous author, and let me just, sorry, I'm going to stop my share really quick because I just realized I need to pull my notes up here. There we go. Zaretta Hammond is, oh, this is a different slide. Wrong slide, sorry. I have many tabs open, as JD will tell you, and it really bothers her, but it works for me, unfortunately. There we go. Okay, so let me share my screen again. Sorry about that. Zaretta Hammond is a very famous educator and author. She wrote a book about 5 years ago called Culturally Responsive Teaching and the Brain. And she talks a lot about how important it is to be culturally responsive educators, because you're not teaching kids just to try to motivate them to learn. You actually want to teach in a certain way. You want your instructional practices to allow your kids to feel stress-free enough for them to be able to turn their attention to learning. You want your kids to feel as stress-free and anxiety-free as possible, because that is the kind of modality in which they'll take in the most information. That's how you'll be the most effective teacher, if they're able to effectively kind of turn their attention and be free of stress when it comes to learning. So the best educators I know have a really good understanding of social and cognitive neuroscience and its role in helping kids accelerate when it comes to learning. So Zaretta Hammond talks about how education is not simply to fill students with facts and information, but to help them learn how to learn. And that's what we'll talk about today. So turning our attention to infants, this is a photo of a little baby wearing a net of electroencephalotic graphic sensors. And it's basically a really non-invasive way to measure the electrical activity in a baby's brain. And, interestingly, I started off when I was an undergrad at Cal doing research in an infant lab. And my goal back then was to actually become a researcher and write papers and study infants. I was really interested in particular in learning how infants learn language and how infants learn math. Believe it or not, babies as young as 5 months old have mathematical abilities. They can tell the difference between 3 objects and 1 object. If you put 3 objects in front of them and then you put up a screen to cover up those 3 objects, and then while the screen is up, you kind of sneak in through through a side door, like a trap door, and take 1 object away, and you only have 2 little objects, they'll look longer. They can actually tell that there's something not right. So we were able to measure in kids as young as 5 months old that they have mathematical ability. But we also measure heart rate, we measure brain activity, we measure how long babies are looking at certain stimuli to be able to tell if they can tell the difference between 2 stimuli or not. And then we also measure, we have habituation techniques that we use too. When kids look away, it's when we realize that they're no longer paying attention, and we can tell what is stimulating to them. And when we put something new in front of them, they express surprise. That's another way for us to be able to tell that they can cognitively process that there's been new information given to them. So that's how we study infant language, infant brain development. When it comes to our 5 senses, the first sense we're going to talk about is vision. So when you are born, when you were newborn, brand new babies, your vision was 6 times worse than that of a normal seeing, like a seeing adult. 6 times worse, quite blurry, but luckily strong enough to be able to look at faces. And that's what babies love to look at most, is faces. If you put a person's face, and then you put a picture of a non-face, like where the features are all scrambled up, babies would much prefer to look at a face than a non-face. And the reason that their visual acuity is so underdeveloped is because they have very poor control of their ciliary muscles. It's a set of muscles in your eye, behind your eye, in your brain, that allows you to kind of focus and kind of focus in and zone in on things. And those muscles are not yet developed. So their vision is very blurry because the structures in their eye are very immature. They do prefer bold and contrasting bright colors. They prefer, especially prefer black and white colors as well. Okay, so let me get this. There we go. They prefer bold patterns. They look longer at faces than non-faces. The other thing that's really interesting about babies is because they have not had to, they don't have the ability to they haven't had their neurons pruned yet. And so between the ages of 0 to 6 months of age, they can actually distinguish between individual primate faces. If you were to show them different primate faces, they can distinguish and tell the difference between each one. Whereas once they hit the kind of 9-month-old mark, they can only distinguish between individual human faces. I just thought that was a fun fact. When it comes to hearing, infants are capable of, and speech, infants are able to recognize their own mother's voices because they can hear in the womb. They can hear their mother's voice. They can hear all different, especially human speech sounds. They are much more attuned to human speech sounds than any other sounds on the planet. They can also distinguish between all sounds, meaning there are certain languages in the world that you may not be able to hear the difference between or hear certain phonemes for, but babies can actually detect all these different phonemes until they're about 12 months of age. Sorry, so back to hearing. Babies also have a preference for the human voice over other sounds of similar pitch and intensity. They prefer the female voice over male voices simply because they've been in the womb and that's all they've heard is their mother's voice. They prefer their own language or their native language, the language that their mother speaks over other languages. And they prefer motherese versus adult-directed speech. So the way I'm speaking to you now is adult-directed speech. It's kind of monotonic a little bit. I'm not really varying my volume and my pitch very much. But motherese is actually a universal trait. Even kids as young as 3 and 4 years old use this kind of special language to talk to infants. You may not realize you're doing it, but actually kids and adults around the world tend to speak to kids slightly differently. They tend to elongate their vowels. They vary their pitch and volume and their intensity more just to try to capture the baby's attention. Okay. Anyone have any questions so far? Yeah, Pari? Pari has a question.
Sorry, I'm in the same room as Lina, so I don't want to cause feedback, but I was wondering, I've heard like certain people advocating for using adult-directed speech with younger kids, as opposed to, I guess, what I've never heard it referred to this as motherese, and I just want to get your take on whether that's better for speech development or it's totally fine.
That's a great question. I think when it comes to infants, that it's really good to use motherese because you're trying to capture their attention. Babies don't know what and where to listen to, but if you want to capture a tiny baby's attention, using motherese you're able to hold their attention longer. But when it comes to toddlers and kids who are learning to speak, so I would say after like say 12 to 18 months, it's still okay to use like a simplified kind of different language, but I would definitely not like use language that's like nonsensical. So maybe, instead of saying like, I don't know, like baba for bottle, like using the actual words, like that's really important. And also correcting their speech too, if they are mispronouncing grammar, or if their sentence structure is incorrect. You'll find that you'll naturally do that when you talk to kids and their speech isn't quite structurally, grammatically correct. You'll find yourself maybe repeating the sentence in the way it was supposed to be said. But the reason adult motherese or child-directed speech is preferable is because for these young babies, that's how you capture their attention. I've heard a lot of adults say like, well, I would never do that. I don't want to do that. But you may actually find when you do actually studies, if you were to actually measure their vocabulary and their rate of speaking, it's kind of a universal natural trait that many adults tend to use when they talk to kids. Phoebe?
Oh, I just wanted to say I've taken a class on language acquisition before, and I think something that was interesting to me was that there's been a lot of studies about whether talking directly to babies is actually necessary. And in a lot of parts of the world, people actually don't really do that, or they don't really like. And that actually is, some people think that's a problem, but I think the studies have shown that the babies are still learning language because they're just listening and watching.
Yeah.
Which I think that's so interesting.
Yes, there's also a big difference between the kind of language that babies are hearing from, like, say, television and radio versus speech that's spoken to them directly. So kids they get so much more information from speech that's spoken directly to them, not in or even around them. They can read facial expressions, they can detect, changes in pitch and volume and tone. It's much easier for them to acquire language from live human conversations and interactions than like television and radio. Same with learning a foreign language too. There's a lot of like foreign language apps that are quite good, like Rosetta Stone and Duolingo. Those are good, but they're definitely not like the ideal substitute for personal, direct interaction with language. Any other questions or observations? Okay.
I just have one more. Sorry.
Yeah.
I just want to ask. I've heard, like, I don't know if you've heard the term iPad babies, like, kind of going around, where a lot of like kids are really, really hooked on to like this like visual and like iPads usually, and it's usually because their parents are like, oh, they'll give it to them and kind of like takes care of them because they're so stimulated. And I guess like it might be too early to really know what the effects of that are, but I don't know if you know any research about like what does that do to the development of a child.
I would always say, I would always favor, again, like live human interactions versus an iPad. I also recognize that sometimes like parents don't have a choice, especially during this pandemic. Like they had to work and they had to get stuff done and they have to get dinner on the table. And, sometimes you don't have a choice. I don't believe in like coming down too hard on parents who do use iPads, because I think or computers or television as a babysitter. Sometimes it's definitely not ideal, but I think there are certain circumstances where it's just as long as it's not in excess and it's in moderation, I think it's okay. I also want to be really explicit too about a lot of parents feel a lot of anxiety and worry about like ruining their kid because they let their kid watch, have their phone for like a half hour longer than they expected, or like, or like all afternoon, or like every Saturday morning. Like it's actually can be quite difficult as long as you're thoughtful and, you're not going to ruin a child forever by giving a child an iPad for like, 3 hours straight or like 6 hours. Look, there's going to be circumstances where that's going to happen. Road trips, airplane rides, you're trying to get dinner on the table. It's just going to happen. My big thing is I think anxious parents can actually create more anxiety for kids, and it's then the actual that actual iPad or computer use. Yeah. Okay, so touch, smell, and taste. It's very evolutionarily important, I think, for all humans to be able to detect things that don't taste good or smell good. Interestingly, kids they're not able to detect disgusting tastes and smells until they're almost 3 years old. The importance of contact, though, is incredibly important, and I think that's what has led to what they found in like the 60s and the 70s, where there are a lot of kids in orphanages in China and in the Soviet Union, where they did not have a lot of caregivers holding and touching babies. And they found that kids later on developed attachment disorders. They had a much more difficult time attaching to a caregiver, a primary caregiver, if they were not touched. And so that is one thing I think every parent and every human being should know, is how important contact comfort is. and touching. And they did a study on, they would never be able to do this study now, but in the 1960s, Harry Harlow did a study of rhesus monkeys. And if you can even YouTube this study, it's in black and white, but they put a wire monkey and a cloth-filled monkey a cloth-covered monkey next to each other. And they put a new baby monkey. They gave it the choice of whether it wanted to be near the cloth-covered monkey or the wire monkey that actually had a bottle attached to it. So the baby could come and go to whichever monkey they chose. And they found that this baby monkey would choose to kind of drink milk from the wire monkey, but then immediately spend like the rest of the 23 hours of the day like hugging and like latched on to this like soft cloth covered monkey. So that's one thing. The mouth is a baby's most sensitive area, which makes sense because they need to be able to nurse. And I talked about smell and taste already. Babies are able to develop, are able to taste in utero. The foods that a mother ingests actually gets kind of dissipated into the amniotic fluid, which is what is surrounding and the baby is immersed in. So they are able to taste and smell the things that the mother is ingesting. All right, so we are going to move on to the brain part of our talk today. The prefrontal cortex. Does anyone know what part of the brain that is? What part of the brain is your prefrontal cortex? JD just pointed to it. Yeah, their forehead. You have a lot of you are pointing to your forehead. Good, you guys remember your bio class. The prefrontal cortex in humans occupies a far larger percentage of the brain than in any other animal. And it's really kind of what sets us apart from other animals. The prefrontal cortex, the prefrontal lobe, is also the part of your brain that governs your executive function. And so does anyone want to define like what are your executive functions? Does anyone care to volunteer to say what that is? What are some executive functions, or what is executive functioning? What are some?
I can try to describe it, but I think as I understand it, it's like executive function is like how your brain chooses to do things throughout the day and like in which order to execute them, which priority to give them.
Yes.
And like doing that consistently and well throughout the day.
Excellent. That's exactly right. Yes, it's the part of your brain that organizes all the things that you have to do during your day. It does all the planning, all the looking ahead, all the anticipating of the consequences of your actions. It kind of helps you weigh, like, well, should I do this first or that first, what you're supposed to prioritize. It's also the part of your brain that helps you experience empathy and what leads you to express care for other people or even yourself. And so a lot of times when we work with kids with executive dysfunction, that's one of the hallmarks. It's one of the first signs of kids who are struggling with executive dysfunction is when they're not able to show empathy, or they're not able to read other people's facial expressions or body language or their emotions very well. So we talk about the prefrontal lobe. It's also the part of your brain that helps to calm down the emotional id responses that emanate from your limbic system. And the limbic system, I'm going to show you a slide in a second, is the set of structures that are deep in your midbrain, right here. That part really deep inside your brain. And it's the part of the brain where your emotions, your memories, and your kind of impulsive reactions emerge. So some of you may have seen this hand model of the brain. Has anyone seen this hand model of the brain before? So there's a researcher named Dan Siegel, and he introduced this idea of the hand model of the brain. And what it is it's a way to show kids, actually use this to show kids how your brain works. So the limbic system would be your thumb right here. It's that inner part of the brain that's deep inside. And then your prefrontal lobe, your prefrontal cortex, is what regulates and calms down that limbic system right in there. So this prefrontal lobe here kind of protects it, it helps regulate it, and it when really like impulsive reactions emerge, it's the part of their brain that kind of helps tamp it down a little bit. Okay, it helps you regulate your mood. However, when you are stressed, or when you haven't gotten enough sleep, or when you're triggered somehow, or when you've been traumatized, your prefrontal lobe is underprogrammed, and it can actually cause your limbic system to just like flare out. And this is what happens. It just your prefrontal lobe just like it bypasses, your limbic system bypasses that prefrontal lobe. And then this is what happens when kids have temper tantrums or they have anxiety. It's that limbic system expressing itself because your prefrontal lobe has not been able to calm it down. So that's the hand model of the brain. And actually it's a really nice thing to show kids sometimes, because it really helps them understand that there's things that they're actually within their control. If you can show them that there are actual structures in their brain that are being activated, it's not their fault. It's not something, it's something, and it can be triggered by, the environment, other people, but it's just it can help actually reassure kids that there's exercises, things that they can do to exercise that prefrontal lobe part of their brain to better help regulate their limbic system. All right, so let me move on to the next slide. All right, so kids who are well taken care of, who've had their needs met in a sensitive, appropriate way, tend to have a better sense of equilibrium. And what that means is they're better able to regulate their moods, they're better able to manage stressors and, to calm themselves down when things feel emotional and things feel difficult. That experience of being cared for by a caregiver, it doesn't have to be a mom or a dad, it can be anyone who's a trusted care provider in a consistent, appropriate, loving way. It leads to a more developed prefrontal lobe. And it's what allows certain kids to be able to calm themselves down and self-regulate and organize their emotions in a more constructive way. Kids who've been deprived or who've experienced trauma, who've been abused, they experience more challenges because that lack of attentiveness, that lack of appropriate love and care can lead to that underprogrammed prefrontal lobe. And other things like, repeated instances of trauma and violence and exposure to situations of chronic terror can actually lead to this overprogramming of the fear centers of the brain. And that can cause kids to become more agitated, more difficult to calm, and more impulsive. It's when those fear centers of the brain get activated over and over again, it can lead to that fear center kind of being the first thing that gets triggered whenever something feels challenging or difficult. Okay, any questions? All right. So what's the opposite of a healthy brain? The opposite of a healthy brain is a toxic brain. It's the brain that says you don't do a good enough job, that your ideas aren't any good, that nobody likes you, that you'll never find anybody who truly understands you. And unfortunately, we live in this moment now, especially with social media and with our current political climate, where I feel like we're all exposed to those types of instances much more than in the past, like much more toxicity than we ever have in the past. So how can we combat that? There's lots of different ways. One thing, and I know you've heard this many times, maybe from your parents or from instructors or mentors, or you've even maybe read it yourself, turning off social media or lessening your intake of social media can make a huge difference, because social media and email alerts and news alerts, and every time you see those alerts come through on your phone, it activates your brain's reward center. And what that's doing is it's actually creating like an addictive effect. It can be quite addictive to see those. You get a little quick dose of dopamine every time you see that new email come up or that news alert come up. So my advice would be to try as much as possible to turn off alerts on your phone, turn off your email alerts if you can, your news alerts. You don't have to turn it off completely, but just be choosy about which alerts you want to pay attention to, and maybe just dial it down a little bit. The other thing is, social media can have incredible benefits. I think in small doses, it can help us maintain, connections and online friends. But definitely receiving constant alerts on your phone can have a negative impact on your mental health. It can reduce your attention span. There have been many more there are higher rates of people self-diagnosing themselves with ADHD and ADD, I think, because of these like constant alerts. Like it's hard to focus on one thing at a time when you're getting alerts on your phone. So it's reducing our attention span and our ability to concentrate and focus. It can also disrupt our sleep, especially if you're looking at phones or a computer late at night. I'm totally guilty of this. I'm terrible at it. But that blue light exposure at night can actually lead to insomnia. And so what they recommend for kids, for example, is to wear like blue light glasses and to also try to not to look at a screen for at least an hour before bedtime. And if you're experiencing insomnia or having a hard time falling asleep, just experiment. See what happens if you limit your intake of, limit your phone use or computer use about an hour before bedtime. And it also lessens your ability to be mindful in your day-to-day activities. And I think that's something, you hear a lot, like how to be mindful and how to be aware and how to be present. And that is definitely one thing I need to work on too, because I'm finding myself like trying to multitask all the time. But multitasking can actually lead to lesser quality work in the long run, for sure. Try to increase the amount of opportunities you have to interact with people in real life, especially now that everything's starting to open up again. I think people are really feeling tired of doing everything online. I think these real life interactions can lead to much more positive feelings, because I think when you're online, you can't help but compare yourself to other people, and it can be really damaging because as you can intellectualize, people are presenting their best selves online, but they're not, it's hard to compare yourselves with somebody's best self when they're online versus, these comparisons that are more based in reality. So that's my soapbox about social media and phone use. So tips for a healthy brain. So your brain is a muscle, so you want to try to find as many opportunities as you can to exercise it. And what I mean by that is they find that like trying to do things differently than your typical like routine. For example, if you're right-handed, try to brush your teeth with your left hand. Or if you're right-handed, try to do something like, showering or putting on your shoes, like putting on your shoes in a different way. Anything to try to mix things up and to try out a new pattern. Trying like a different way of going to school. If you're walking to school or biking or driving, take a different path. All those things just to kind of shake things up in your brain so that you're not on autopilot is a form of exercise for your brain. Eating with the opposite hand that you're used to eating with. You want to be constantly creating new pathways in your brain. I like to think of the brain as like snow, and you want to create like new tracks in it, like as if you're like a deer. You want to try to create new paths in the snow for your brain to kind of chew on. And so, doing things with your eyes closed even, the more you can recruit different parts of your brain to do the activities that you do normally anyway, the better it is for your long-term brain health. Okay, I'll say that again. So the more you can try to recruit different parts of your brain to do the activities that you're always doing anyway, the better it is for your brain and for your long-term brain health. So even if you talk to your parents next, that's a interesting tidbit to share with them too, because your parents are probably about my age. Believe it or not, you can build new brain cells that have connections to other brain cells well into your 80s. Okay, your brain will still be growing and developing and making pathways into your 80s and 90s until you die. You're always going to be making new pathways. So it's a myth that, I know it was a commonly held myth that we're only using like 10 to 25% of our brains. It's a total myth. The more you can constantly create more pathways and trails within your brain by learning new things, by experiencing new things, by trying new activities, doing things that are atypical for you, but or doing things in a different way, the more you can generate these new brain cells and new functional pathways in your brain. So new activities, new people, new experiences, new languages, word games, puzzles, Sudoku, math games, all of those things that exercise your brain. Those are all really really great for your brain. And also doing things out of your comfort zone too, like challenging yourself to do something that you've never done before will help also build new pathways. So, try to find any opportunity you can to say yes to, something that puts you at risk, not like your life at risk, but like something where you may not experience success the first time. That is building a new pathway for your brain. And as I mentioned earlier, multitasking is not ideal. Try to minimize it because, even though it's just a millisecond, your brain is still having to expend a certain amount of energy as it's switching from task to task. So you might think that you're doing something simultaneously with, good, like in, good quality, but you're actually probably not 100% focused on either task. And I'm really guilty of that because I sometimes try to grade papers when I'm watching TV, and it takes me like 3 times as long, even though I tell myself like I'm multitasking, I'm doing 2 things I like to do at the same time, but it takes me 3 times as long to grade papers. And anyway, yeah. So back to executive functioning skills, I just wanted to review really quickly, like when it comes to your kids, I would love it if you could take a second right now to visualize one of the students that you work with. Just imagine one of your students that you work with. It could be a student who's, you're really proud of and who's making tons of progress. It could be a student that you're, finding has a hard time retaining information. But I find that it's nicer to think about these types of skills when you can apply it to somebody. It helps you remember it more. And even if it's for yourself too. So the executive functioning skills, as Pari and I talked earlier, it's the skills that govern how to start activities or tasks or a project if you're learning how to code, for example. Planning the project, knowing how much time that project is going to take, being able to tell stories in an organized, sequential way, memorizing and retrieving information, generating ideas and retaining information while doing something else. Those are all executive functioning skills that we feel are really important for our kids to be able to know how to do. There are certain kids who are incredibly smart, incredibly bright, but they just have a hard time maybe regulating their behavior. And so there's certain students who don't have any problem at all receiving or absorbing information, right? You might have a student like that you're thinking of. They have no problem receiving information and absorbing it. But what they struggle with is they don't know how to organize all that information. They have a hard time deciding what to do first, or even like how to behave as how to regulate their behavior, their body as they're taking in this information. They're highly intelligent, but they lack the executive functioning skills to put that to use. So these are the types of kids I want you to think about now, if you can, amongst your students. It's really important, I think, to model for your students that executive functioning is something that can be practiced and learned. And you don't have to like literally say that, but there's certain strategies that I'm going to talk about next that will help them overcome some of these executive functioning deficits. And a lot of kids are going to need some extra support. You might find some of these helpful. So the way to try to, I keep accidentally, there we go. The way to try to encourage executive functioning skills is to create a culture that encourages mistakes, right? That it's okay to make mistakes, that it's okay to use different strategies. And our job is to really teach kids how to be learners and not to have the answers already. We don't expect them to already know what to do and how to do it. So it's our job to provide them with support that's super structured, right? So one example of that, you could maybe write down on a whiteboard or write down on your in the chat when if you're teaching over Zoom, is to write it like just a quick like bullet point agenda. Like, this is what we're going to cover today. We're going to review what we covered last week. We're going to work on your Scratch project, and we're going to try to figure out what that bug was that wasn't making it work up to the next level. So making like a small list with the student about what they can expect at the top of the hour can be really effective. And having it be visual or tangible for the student too. Kids, especially kids who struggle with executive functioning and attention deficit, they need things to be visual, as much externalized and visual as much as possible. But that also needs to be taught and modeled by you. And I think it's really good for them to see you doing that too, because they will then transfer that exercise, transfer that practice to themselves at home too. So maybe when they're doing their own homework or they're learning something new, they can do that. Having tasks and the things that they learn be explicit and chunked out into sections so it doesn't feel totally overwhelming. It can also be a really kind of external, visual, structured way to help kids manage lots of information, lots of input all at once. I think also emphasizing practicing and strategies. JD, did I see your hand raised? Oh no, okay. Does anyone have any questions, by the way? I can't see everybody on my screen at once, but anyone have any questions? Okay. Yeah, we're almost done. So reinforcing and noticing when they use the strategies, like if you see them making a list or you see them kind of chunking it out or something like, or if they're even talking out loud, definitely call it out, reinforce it, tell them like, oh my God, I'm so impressed that you knew how to do that. Like just tell them all the time, like positively reinforce any kind of practice that you see them, any strategy that you see them utilizing. And then also when it comes to presenting new information, it's really helpful if you can scaffold it on like a new concept onto something that they already know. So scaffolding it onto like some kind of prior knowledge that they already have makes the new information much more readily absorbed if you can connect it to something they already know. That's probably like common sense for many of you. But modeling and practicing thinking out loud is a really helpful strategy too. I think modeling that and saying, okay, so this is what I'm going to do first. I'm going to first, and then just modeling how you would do it. I think you would be surprised at how much your kids look up to you and how much they want to be like you. And if they see you doing these things, like you're a college student, like they will be so impressed by that. And then encourage self-reflection too. You can ask like, do you remember the last time we drew out what that game might look like? Did you find it easier to figure out where to start your project? Like model that, model like reflecting and like kind of talking out loud with them. I've noticed a lot of you doing that anyway. I hear like when I'm walking by, I can hear you all asking like, do you remember that time? Or like, oh, I remember the time when we did this. Like all of those like connections that you're making to previous projects. It's also incredibly helpful for kids to see you doing that. This is long. I'm going to share these slides with you, but I'm kind of repeating what I said before, but visual, like everything visual as much as possible, everything visual, and having, modeling and being flexible, having a sense of humor, showing them that you make mistakes and that you don't know the answer to things is fabulous. Kids love that. They want to know that, we want them to know that we're not, we don't know the answers to things either. Even for yourself, if you feel like you struggle with executive functioning or with ADD or ADHD, externalize tasks whenever you can. So it doesn't have to just be lists, but it can be like pictures of things or outlines or having timers. I find that really helps me to have a timer. If I have a hard time starting a project, I don't want to do it, I set a timer and I'll say, okay, I'm only going to do it for 8 minutes. I'm only going to like listen to this, boring podcast for 8 minutes, or I'm going to sit here and write this email. I'm going to try to knock out as many emails as I can in 8 minutes. Just choose a realistic number. Don't do like 15, because that can seem like a really long time. Who wants to do it for 15 minutes, even 5 minutes? But kind of get the ball rolling and kind of get yourself on that downhill slope can really help jumpstart your productivity. What else? modeling strategy. Oh, and then the idea too is that you'll be eventually able to slowly hand off responsibility to your students to be able to remember to do these things also. So let them see you do this and then model for them how to do it, encourage them to do it, and pretty soon they'll be able to do it on their own. Let's see, there's something else I wanted to mention, but okay. The last thing, these last two slides I found really fascinating when I first learned about this, I think back in like 2008. It was really eye-opening for me to understand, especially kids who struggle with ADD or ADHD. Kids with ADHD and ADD, and also like kids on the spectrum too, or kids who struggle with executive functioning, a lot of times, the thing that's hardest for them is they have a really hard time picturing what the final product of something is supposed to look like. So a lot of times if you ask a kid like, I need you to make this diorama for your 4th grade, missions project. Like, so, here are the instructions for your diorama, go do it. A lot of kids have a really hard time with that because it's super vague. They don't know what a diorama looks like. They may have like some idea of it, but they have a hard time seeing what this like future abstract thing is going to look like. So then that totally overwhelms them and they have no idea even how to start. And so I wanted to just talk about memory here. So long-term memory is like your crystallized memory. It's the memories that you've made that are deep in the structures of your brain that you're going to remember until the day you die. Okay, think like childhood memories that you made. Short-term memory is kind of like the kind of memory you might have if you're trying to, it's kind of like a mental scratch pad, right? Where you hold information in your mind until you can use it. So things that are kind of meant to be temporary. It's like, pictures that you saw where you left your keys, for example, like those are all like non-verbal working short-term memory type things. It's not necessarily words about the future, but it's actually what the future looks like. And kids who struggle with nonverbal working memory have a hard time knowing what that's going to look like. They have a hard time keeping that picture in their brain. And so what we do, what great way to help them remember is helping them know what that done thing is going to look like, what it's going to look like when it's done. So neurotypical people can imagine what done looks like easily, and they can kind of figure out how to work backwards from there to figure out what steps to take next. For example, a common example might be making like a peanut butter and jelly sandwich. This is a commonly used example, right? So if you tell a neurotypical person to make a peanut butter and jelly sandwich, the first thing they're gonna do is they're gonna picture what that sandwich is gonna look like instantly, right? What does done look like? And then they backwards plan. They know what steps they have to do to get that done. They have to get the equipment they need. They have to get the cutting board and the knife. They have to go get the bread and the peanut butter and the jelly. They have to lay out the bread. They have to spread, they use the knife to spread, they're picturing themselves doing it already. They're spreading the peanut butter, spreading the jelly, putting the two sides together. They know what they need to prepare to do those steps, and then they're done. The kids who have a hard time with that, kids who struggle with executive dysfunction, who are neuroatypical, they can't see what that done peanut butter and jelly sandwich looks like. They can't see what the finished product is going to look like. And that really is what holds a lot of kids back. So what our job is as their coaches, as their teachers, as their parent, as their mentors, our job is to make the done visible and visual for them. So it might mean for you, for example, showing the project that they're going to make, or showing an example of the project, or drawing out what the code might look like what, helping them draw it out first. They need to be able to picture what the done looks like in order to know what to work towards. It can be incredibly overwhelming, I think, too, to have all this huge task in front of you and not know where to start because they can't see what they're working towards. I know I'm like repeating myself, but I can't stress it enough. It's that finished product that kids need to be able to know what it looks like. What we did for, there was a kid in first grade that I worked with who really struggled with routines, who could not sit still on the rug, who come in and like throw his backpack all over the place, was always losing his water bottle, always losing his lunch, could not figure out like how to stand in line. And so what we did for him was we went and we took pictures of him doing all the things he was supposed to do. And amazingly, having that picture, like we took pictures of him, like sitting quietly with, like sitting on the rug, took a picture of his backpack hanging on the hook, took a picture of him writing at his desk, took a picture of him like drinking water. Like we took a picture and we laminated all those pictures, and we hung it onto like a little key ring, like a little 3-ring binder clip, and we could show him like, this is what we need you to do. And boom, he was able to do all those things because he knew what done looked like. Like just being able to visualize what that done was going to look like made a huge difference for him. So this is my last slide. Structure is the key to everything. If you can structure as much as you can, make lists, make agendas, make an outline for them, it reduces anxiety and it makes the uncertain, unknown thing into something they can actually see. So a sample of the finished product, examples of a completed project are really good examples to share. For kids who are having trouble starting on projects, this could even be you. This is definitely one of my kids. Show them what done looks like and share something that they've done before. I have a kid one of my kids gets super anxious before going to any kind of social event. And so what we've done is I've gone and I've helped them identify like, okay, so we'll kind of talk through like, we're gonna get in the car, we're gonna go drive to this place, you're gonna unbuckle your, like just talking through what that is gonna feel and look like. I've taken pictures of kids also like at birthday parties sometimes, and taking a picture of them, what a birthday party is going to look like, what it might look like with a cake and balloons and a lot of people. You can even Google photos of a venue sometimes for people. That can really help, so they can see what the outside of the building is going to look like. You might take a picture of kids eating cake. That immediately lessens anxiety if you can make the uncertain unknown into something that kids can see. Another thing is, telling a kid like, okay, go get ready for school, or sign into your Scratch project. Like that can feel overwhelming too. So you can also like just help them like write out the steps involved, like go to sign in, like walk them through that step. I know it might seem tedious to make all these lists, but that can also reduce the anxiety too if they know what these unfamiliar things are going to look and feel like. And finally, kids who are having trouble like starting on a new project with some, like say in Python, if you've been working in Scratch, like showing them like, here's what a finished product looks like, and then show them what the kinds of code that they've already accomplished, and try to help them see that they can actually take the steps to get there, to identify the steps and the parts that are how similar they are to be able to apply to what they're going to learn next. Okay. That was my last slide. Any questions? I threw a lot of information at you. It's all on my, I'm going to send you all a link to this slide deck. And like I said, I hope you can try to visualize the students that you're working with, because it really helps to apply it. You're better able to retain and apply this information if you can try to apply it to somebody that you know. Thank you for sticking with me. I see a chat here.
Okay, just real quick, I want to go down the list. Oh, is that when I roasted you?
Yeah, I didn't read that until now.
I wanted to go down the list real quick and make sure I got everybody. Brandy, Eddie, Kaveen, Lucas, Nico, Ozzy, Kari, Sophia, Theo, Stephen, Phoebe, Jennifer, Lena. Did I forget to call anybody? Perfect. I just want to make sure y'all get paid.
Oh, wait, I'm gonna take a screenshot.
I'm gonna show you how to actually wait. Okay, I'm gonna do it right now. Everyone, don't worry, I got it. I got an actual screenshot.
The only way I know how. Thank you guys. Thank you so much. Thank you for coming to this tonight. Thank you for coming on Saturday. It's so great to see you all, and I'm excited to have you all in person here more and to feed you more. And thank you so much. Have a good night. Have a good week.
Lena.
Thank you,
Lena.
Bye. Thank you.